everybody, we're going to talk about your third exponent law today, and that's your power or exponent rule. What this is just when you have a base that has exponent and then it's surrounded by another bracket or parentheses and then it is raised to another exponent. I know that probably didn't really make any sense, but here's an example of what I just said. If you have a number 5 and has exponent of 2, and then you have brackets that's surrounding it, and then you have another exponent that's outside of it. So the rule here is simply put that you're just going to go and multiply these two exponents together. So your answer is 5 to the power of 6. Or if you have another one that looks like, say, 2 to the power of -6, and then 3, this simply becomes 2 to the power of -18 because you're just multiplying those two numbers together. Another example could be just, say, I'm just keep using 5 here. 5, -4, and then -2. And this becomes, the base is the same, so 5. And since these two numbers are multiplied together with the negatives, this becomes +8. So this power rule is pretty straightforward, and to illustrate how that works is that if you look at this one, if we were to do this in expanded form, 5 to the power of 2, I'm just going to rewrite this, 5 to the power of 2, and then brackets to the power of 3. If we were to write this in expanded form, this is just like this, 5 square times 5 square times 5 square, because I just made a copy of this 3 times. So since I have this, I can further expand this. So 5 squared is 5 times 5. That dot means 5. This means 5 times 5. And this also means 5 times 5. And since their brackets are right beside each other, if you remember from the fractions unit, the brackets are right beside each other, they're multiplying together as well. So we can notice that this 5 times 5 times 5 times 5 times 5 times 5 is written in an expanded form. And if we were to write this into exponential form, we have the same base. This is what we photocopied or from my video, previous video. That's what I photocopied. How many copies do I need? That's 1, 2, 3, 4, 5, 6. So that's how this exponent or power rule works. So simply, it's just if you recognize that you have exponent and there's a bracket or a parentheses surrounding it, and there's another exponent on the outside, you just multiply them. Don't add, multiply them. And if you're always unsure, you can always put these in expanded form and just really count the number of copies. And that's basically it. If you have negatives, well, it's just negatives times your positive. 2 negatives makes it positive. And that's straightforward for exponent law number 3. The last law we'll talk about is the fourth one. I don't even think there is a name for this. I think this is just recognizing this pattern. So what this sort of law talks about is that if you have a base and then multiply to another number with a different base, all these ones are surrounded by parentheses or a bracket. So you can see there's a bracket here and there's a bracket there. Oh, that's not a very nice bracket. There's a nice bracket here, there. The key thing here is that they're being multiplied to each other. So this is multiplied. And then you have an exponent on the outside. So what basically this is saying is, I'm just going to change color right now. But what happens is that this exponent just gets multiplied to that one and multiplied to that one, sort of like a distribution. So you're just distributing this exponent to both of these. So your answer becomes 3 to the power of 8 times 4 to the power of 4. And that's really what the law is about. And this only happens, you can only do this if they're multiplying together. And even if they have the same base, you can do this. The reason behind this is that because they're multiplying, you're allowed to do this. If you were to do this with plus, this wouldn't work. So if we were to have another question, say 2 times 5 times 100 times 51, that's not 5 again, and I have exponent 6. Well, this seems like a lot of things to do. Oh, let's put some exponents in here. There's that one, and there's that. So this seems like there's a lot of things to do, but basically, to simplify this, all these exponent laws are not really laws, but it's just a shortcut method. It's just recognizing this pattern and see if you can create a shortcut for yourself, so instead of writing everything out. So the shortcut here is that you're just multiplying this exponent to each of these exponents. So this 51 doesn't have exponent, but it does have an invisible 1, so there is a 1 there. So your answer is 2 to the power of 12 times 5 to the power of 12 times 100 to the power of 60 times 51 to the power of 6. And that's it. And once you get this, if you really need to evaluate these individually, what you have to do is, the next video we're going to talk about your order of operations. That means that you actually have to follow a strict order in how you perform these operations. So since all these ones have exponents, you have to go and find the answer to this, 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 and then this, and then finally once you get all the answer, you're going to multiply them all out. And I don't have a calculator on me, and these are pretty big numbers. So if you want to do this, punch this in calculator, you get a big number, big number, big number, big number, and you're going to multiply all this. The reason why this works is that if you go back to this example, like 3 to the power of 2, 4 to the power of 2, let's say, to the power of 3. Again, if you're unsure of any of these exponent stuff, and if you don't know what to do, you can always just write an expanded form first. Remember, this expanded form, if we were to write this expanded form, we're going to work with an exponent on the outside, because this exponent includes all the stuff that's inside this sort of box, or the brackets. So if I were to write this in expanded form, you have this times 4 to the power of 2, and then I have 3 copies of this. And what you're going to notice is that once I write all this stuff down, I can further expand this. So this is going to be 3 times 3. I'm going to keep my bracket just to keep everything tidy. And then this multiply sign is going to stay there. I'm just going to change the multiply sign so that you know it's different than the dot. And then 4 square is 4 times 4. And I'm going to close my bracket. So this bracket, this box includes all this. And I'm going to start my next bracket, so it's exactly the same thing, 3 times 3 times 4 times 4, close bracket, open bracket, 3 times 3 times 4 times 4. So this is the expanded form of this is the expanded form of that. So you notice that this is a multiplying, multiplying, multiplying. Between brackets, this is multiplying. So you can see that in multiplication, there's a lot of different ways to symbolize multiplication. All these ones are multiplying together. So in essence, basically what you just did was 3 times 3 times 4 times 4 times 3 times 3 times 4 times 4 times 3 times 3 times 4 times 4. Right? That's what you just did. I drop all the brackets because they're all multiplying to each other. I just changed the multiplication sign because it's exactly the same. And since they're all multiplying, I can actually rearrange these order in any way I want, and it still be the same. So I can write all the 3's together. So times 3 times 3 times 3 times 3 times 3, and it's going to be multiplied to 4 times, not 44, times 4 times 4 times 4 times 4 and times 4. Now you notice now this, if I were to write this in exponential form, my base is like that, and my exponent is 6 times 4 is my base, and I have 1, 2, 3, 4, 5, 6, bam. And you can see that going back to your original, your shortcut here, instead of doing all the expanded form, you just have to multiply, as long as they're multiplying together. Because if they're not multiplying together, this wouldn't work. If you try putting a positive sign in between, this wouldn't work. Your number is going to be different, and it's going to be different than you multiplying, and that would be incorrect. So make sure whenever you're doing this, make sure you recognize, are you multiplying or addition or adding, because that will determine your really correct answer. And that's basically it for the last law, and that's all of the exponent laws you need to know. This would apply for anything, your algebra, A's, X's, anything, as long as they're multiplying and exponent and brackets with an exponent on the outside. So hopefully this video helped you prepare for this unit, and next video is going to be talking about order of operations. So I'll see you then.